Hey everyone, it's Andrew Brown, and I'm joined here with Rola. And so we are going to be working our way through the GenAI roadmap. I believe earlier in the introduction, I described this as a maturity model. And so originally, this was a very, very detailed a flowchart or roadmap that Rola had produced along with,
Dawn,
with
Rachel.
Don. Yep.
Yeah.
Don. And so I took it and I mangled it, or I should say I reorganized it into what I call a maturity model, where the idea is that we can step through it and have a way of understanding where we might be in our journey in terms of a GenAI roadmap. By no means is this an exhaustive list. There is so much in GenAI, but I'm hoping that for those that are starting to try to understand GenAI, that this will become a way for you to understand it. And then once you have that core knowledge, then you can be introduced to something that is a little bit more complex or robust. And so what I want to do here is I want to walk through with this with Rolla and just confirm that we have a good scope of learning here. In terms of the course that is here, not everything is included in the course just because of the strict time limit I had to produce this course, but I still want everyone to see what the scope of what I think people should learn. And so we'll start at the top. And actually, we do have a lot of content in the course that is not in the ML introduction, but I think that if you're going to learn generative AI, you probably need to have some understanding of machine learning. Rolla, do you think you can skip it, or you think it's an absolute necessity to have some basics of ML?
I think it depends on what you want to do. If you want to be just a practitioner who sets up a single system, maybe you can skip it. But if you want to stay in the field, you probably need some understanding of the bigger picture.
And I think with lots of things, you can get away with not knowing for a while, but at some point you will have to learn it. And sometimes it's better to learn something earlier on than to push it back later. I don't think a lot of these things are that hard, like vectors and embeddings, or I mean, at first they seem very intimidating, like seeing the transform architecture and all those moving parts. But I think there's a lot of content out there that does break it down into smaller parts. And I would just say it's like you don't have to be a mathematician to fully understand the basics of ML.
No. And you don't need to be a car mechanic to use a car, right? If you want to rent a car and use it once, that's great. But if you're going to use it every day, if it breaks down, you need to know where to look, right?
And also, those who are watching, we're both a bit tired because yesterday was New Year's Eve, and so I was passed up past midnight, and I think Rolla as well. So just understand our energy levels are high in our minds. but but anyway, so after you learn some basics of machine learning, I think that sets a good basis to now come into generative AI. Obviously, I think that a lot of people are interested in agents. I think that's what's talked about a lot these days, at least in what I hear when we talk about Gen AI. So there are some things like agentic workflows and agentic coding. It's a bit odd that I put them here because these are very advanced topics, but I put them in here early just because I know people want to know about them and talk about them, and so it wasn't more so to dive into these things in deep, but more just to tell people, yeah, this is the end goal of where you might to go, if that makes sense. Obviously, responsible AI is maybe a higher priority for folks. I'm not sure what could go in here, but even though this part looks really small, basically the Gen AI introduction is more so like I don't know, like this part here. Um, but yeah, that's what I have for the Gen AI. But I think one thing that is really interesting is the modalities of generative AI. And I think that a lot of folks just focus on text generation, LLMs, but there is this whole skew of things: video generation, 3D generation, image generation, audio generation. Are there any more types of generations that I'm missing out on there, Rola?
I think there's a bunch on protein and DNA, which, I mean, they can look like they're text, but they're specialized types of text. There's a lot to do with protein folding and things like that that have also been used in Gen AI. So there's a few very niche topics, but these are the main ones, I think: text, image, video, audio, 3D. Yeah, those are the main. But there are niche topics that have to do with health science or very specific
Mm-mm.
fields.
Well, it's a bit tricky there because like you look at images and videos, and a video is just a series of images, or you have 3D and 3D or 3D files, and they're just vertices and text files. But yeah, I guess there are specialized ones. And that's the thing is I don't know of anything beyond, as you said, like things in the health sciences. Health sciences, if there's anything else that we would consider a modality, but these are the main ones. One thing that's kind of really hard to figure out is like if you have video to video or image to text to image, is it the modality of text or video based on if it has one or the other? The way I put them in is like if it outputs that thing, then I put it in that modality. But I'm not sure if we have to think about it in such clear cut binary way of thinking these type of inputs outputs for these different types of models.
No, and I think we put them there initially to just give people the idea that there is a lot beyond just text generation, right? There's a whole slew of things happening. And what usually happens is if you look at a model card, if you're looking for something specific and you look at a model card, they will tell you what the input and output to that model is, and you look for something very specific. So I think it's just enough to know that other modalities exist, both in input and output, and that you can find uh, a model that suits the input output combination that you are interested in.
And I think that since the creation of this flow chart, actually, there's been an explosion of video generation tools that I can't even name them all. So that's why I'm kind of hesitant to put names here. I mean, Whisper is still hanging around for audio generation, but yeah, for video, there's everybody has one right now. And so I don't know. It just kind of shows like how fast things are moving. Even in a few months, like there'll be just an explosion of models in those
It's
areas.
moving
But
very
when you know
fast.
the basis of these things. Mm-mm-mm. But if you know video to video, you know what video to video is, right? At least at a high level of what that means, because underneath that could mean something completely else.
Yeah, and it's
Then
moving
for
very
text,
fast. I think all of the most of the things that we've seen in the public eye are about 2 years old at the moment. So whenever you read an article on Gen AI or something, notice the date because things get outdated very fast.
well, it's also really hard to figure out what to include practically because
Mhm.
as I'm doing stuff, everyone's like, "Oh, use that. Did you hear of this?" Constantly, "Did you hear of this? Did you hear that?" And I'm just opening these things and going, "Well, which is relevant and which is not?" But I think that
Mhm.
even if you do use a tool that might become dated, I think that there are things that are always going to be in that realm of that kind of stuff, and so it's not fully wasted information. You just kind of have to move as quick as you can, and you're going to have to expect that things are going to be the floor is going to be moving around on you all the time. Yeah, for text generation, text to text, single turn, multi-turn. I have multimodal, multi-model. A lot of terms that seem very similar. Now we're into LLM basics, which is still generative AI. A lot of stuff here. We have a repeat of ethics and bias because we have responsible AI, which have some overlap. Um, and so, looking into LLMs, probably the most important thing is understanding, I don't know, like tokenization, autonomy of a prompt. I'm not sure what else there is there, but yeah, if you fundamentally understand, I think like what a context window is and what it can do, then you have a lot of power just with LLMs there. Like we have it, we're like I'm supposed to have a section on prompt engineering down here, and even this, I didn't do all of the videos, but I realized that as I was making some of the content here, I subconsciously was utilizing some prompt engineering techniques that I wasn't aware of. And I'm not sure how much value there is to like learning every possible prompt engineering technique because there's walls and walls of possible ways that you can do things. But it is really interesting that if you just have an idea of creatively how you can feed stuff into prompt engineering that you might implicitly be doing them. How much do you keep on top of prompt engineering techniques? Do you feel that it's worth going learning all 200 of them, or um,
No, no, I don't. I mean, things are going to keep changing. I think the main things that have shown promise are good to know, and those are usually a handful of things, right? And we can talk about them in the course. I think understanding the anatomy of the prompt is really important. That's what's going to allow you to understand, um, what you can do and how that affects the model. I think that's very important. But there's going to be a lot of papers and a lot of understanding of things as they come. I don't think they all move the needle in huge ways. Those that do, you'll hear about, but I think those are a handful. You don't need to know all 200, no.
In terms of AI powered assistance, I feel like that's one of the first entry points that a lot of people have with generative AI. But you know what? When it came to these videos, I didn't have much to say because they're all kind of the same, and there's not that much functionality built around them. Now, some AI powered assistants have some bells and whistles, like Claude has the idea of projects, or ChatGPT has that really cool voice feature, or Google Gemini, they supposedly can process larger types of PDFs, and the way they do it is special. And actually, I think AI 21, I don't know, they have, or AI 21 technically has an AI powered assistant, but some of these things here, they're not intended to even act as AI powered assistants. They're just there as demonstrations. So, like when you go to Meta or Mistral, I don't think you're supposed to use them as your day to day AI powered assistants. It's mostly just to show you a means to do that. Um, but with your level of knowledge, do you use AI power assistants, or do you roll your own, so to speak? Um,
I tend to like to do things my way because I trust my own systems. We do rely on Anthropic Claude quite a bit.
mhm.
My team uses a lot of Cursor for coding and things like that. Uh, my main issue is the probability. I would like to understand what the probability confidence in any particular response is, which right
Oh,
now,
okay.
yeah,
Because
which right
it
now
doesn't
is
it doesn't tell you, right? It just
irrelevant.
gives you an
No, it
answer you
doesn't
wouldn't
tell
even
you.
know. Yeah, yeah, I never even
Yeah,
thought about that.
yeah.
So, but I guess like when you're using models directly, would they give you probability, or would you have to do some post calculation to get that?
In predictive AI, most models give you some sort of probability of confidence, some sort of measure of how well it thinks it did.
Mm-mm. But but we were talking about just general models, like any kind of ML model. Is that what you're saying? But with LLMs, would they also explicitly return them as well, or?
No, so most LLMs do not because they're generating sequences word after word. They do
Mm,
not tell you what the what the models how well the model thinks it did. But in other
mm.
probably if you're doing a classification, for example, it would tell you what its
I
confidence is.
so I guess that's a good thing. Is a good thing that you said there, because when we talk about LLMs, you have to. Everyone talks about having evaluations, right? But
Mhm.
is it because the nature of LLMs makes it hard for it to produce that number, so you have to have an additional step? Whereas when you're using a classical machine learning model, it's producing a single value, and then it can also give you the probability back at the same time.
Kind of. So in predictive machine learning, traditionally it was very task specific. So you trained it on a very specific task. And so it learned that task and it gave you some sort of metric of its performance on that result. Now, generative AI tends to be, and foundational model LLMs tend to be more, they're general purpose. So they can do a lot more things and they can do different types of things beyond the things that they were trained to do. That's where all these evaluation metrics come in, is if you see, and we talked about this at some point, um, is they would tell you how does it benchmark on coding, how does it benchmark on reasoning, how does it benchmark on accuracy, because they can do a lot more things than we train them on because they're very, very large models, and so there's emergent properties that come with that.
Mm-mm. Um, and so I'm just going to iterate here that AI powered assistance is, I think, where a lot of people start learning it. But what happens is that when you're using AI powered assistance, you find out that it doesn't have a programmatic way for you to start implementing it for your own solutions. And the purpose of this course is to show folks how to go beyond the AI powered assistance. Of course, you can leverage this course to do the best that you can do with AI powered assistance, but you really want to move beyond it. And this kind of part here, I almost feel that I should have a little line here, because this is where the real story starts, right after. Oops, that's not what I wanted. But if I can get this open here, it's not. I don't know how to get my shapes. Here's my shapes. But I feel that right here, yeah, if I was to draw a line right here, this is where things start to get serious. It's obviously an arrow, not a line. And so this is where you start to get into workbenches and playgrounds. Surprisingly, I showed where all the workbenches were and playgrounds were in these various solutions, but I didn't really use them. I just skipped right over to code because there's not much to talk about. They look a lot like AI powered assistants. They do have more knobs to turn, like what top K and temperature and things like that.
Mhm.
But once you learn one, they all kind of feel very similar. But some of them will have interfaces to their extended functionality. So, like if you're using a Cohere, they would have a little box for the response format for JSON. If you're in Anthropic, then if you want to do tool use, you could do that in place. And some of them will generate the code for you, so you can start utilizing them. And sometimes they generate good code. I can't say they always do. I think in some of them, they're actually producing older code. I'm actually really surprised with how many AI services, like they'll have a version 2 API, and then their main service that generates the code is still doing version 1. And it almost kind of feels like these companies can't even keep up with their own changes, which is really surprising.
Mm.
But I'm not sure what your experience is about documentation and how accurate it reflects the current versions of things.
Usually they're behind. I think part of it is the speed of things, but also I think part of it is cost, right? The older model is likely smaller and is likely cheaper, and so some of it is cost.
Mm-mm-mm. So, once you start working with things programmatically, at least in this way, before you even start writing code, you might start to think about what kind of models you want to use. And there's all kinds of models out there. There's foundational models. We have models that are fine tuned, which technically foundation models are fine tuned models. Models that are instruct models. We have embed models. We have open source models. We have edge optimized models, or we could call them SLM, small language models, or we could call them on-device models, or we could call them something else. There's a lot of names for this one in particular. And then we have uncensored, or you could say unrestricted. I don't know, the word uncensored doesn't sound good, but unrestricted models. And we have a lot of models. Why do we have so many darn models?
So I think these are all different terminologies um, to describe different metadata about the model. So open source models are models where the weights are open, um, plus the data, plus the code. Open weight models are models where the weights are open, but not the data and the code. So each term describes a very specific scenario. So edge optimized models are usually smaller models that you could put on your phones and edge devices, as opposed to the larger models that need a server. So because there's so many different um, ways that you could use these things, you have to have words to describe the different situations, I guess.
And I think there's probably a lot more open weight models than there are open source models. There
Yes,
might
I
be
think.
a bit of a confusion between that, because I always think like I was like, this is an open source model. I'm like, but is it? I mean, I can download the weights and I can do things with it, but I don't really know how they've trained it.
Yeah,
I
so
know
I
there's
think
like one model out there.
Mistral and Meta tend to be open weight models, but they're not open source
Mhm.
models. So the data and the
Yeah.
code that generated the models are not there. Um,
Mhm.
OpenAI and is a closed model, and
Mhm.
Anthropic is a closed model. Um, yeah, so there's different ways in which these things are released, allowing people different types of control, and that's where the naming comes in.
And I like how, if people are watching here, yes, I'm updating the this as we go, because that's how it is. You collect information and you find new ways of organizing it. I know of one open source model that I can always remember, which is IBM Granite, because they say that their model is truly open source, and by that they mean like you even know what data was sourced to train the model. So it's really interesting, the different levels of things there. We have model as a service. So I think this is probably one of the easiest ways to start working with LLMs, and some other modalities where they provide a unified API to access to multiple different models. And so Google, Amazon, Azure, and Alibaba all have them. I haven't tried Alibaba yet. I just know that they have it. And I said I was going to go use Alibaba. I never did. Is there any other ones that are out there? The only other ones that I can think of that are model as a service is Grok, GROQ. For those that are listening, there's a lot of Groks in the AI space, and it gets a bit confusing. But that one was amazing. However, they don't have a paid tier. So like you can use it and it's super fast and it's only for open source models, but they don't have a payment plan, so you can't even utilize it for production. They do have a business plan, but it's a bit hard to get in there. And so once we're done with models of service, now it's time to get serious, and we're actually looking at like some of these are cloud services, but now we're getting into very serious development, and this could involve actually downloading models to your computer or using best-in-class third-party cloud services. And so this is not exactly organized the same way as the course, but now we are into dev tools and workflows. And so something that folks probably should know about is the GenAI lifecycle, LLM ops. These are concepts that sound very similar in the cloud space when we talk about, I don't know, the development lifecycle and DevOps, but they can be applied there as well. And then there's just some core developer tools that I think that people are always going to come across. Like I'm on Hugging Face all the time. It's like the GitHub of
Mhm.
the AI ML world. I was surprised that I used Olama more than I thought. Do you ever touch Olama, or is it it's not for you, Rola?
I haven't, but I know people love it. It's open source. There's a lot. It's a lot more open than a lot of other systems, so people like it. I haven't personally played too much with it, but yeah.
I don't even
Anything
remember
open
what.
is great.
Oh, sorry? I don't even remember what LMS is. I'm not even sure what that is, but it's in there. So I can't remember. That must have been something at one point, but now I don't know what it is. I'm almost tempted to delete it. We got Llama file, LangChain, Llama index. These two things were things that I heard a lot about early on when I was learning about generative AI, and I actually ended up, once I started gaining so much knowledge, I don't even touch them at all now. I don't even think I even bothered to teach them, because even though they were, I think they're actually really good as a learning tool. I just found that the promise of what they were supposed to provide was to give you an opinionated framework so you could rapidly prototype things. But because the space, again, has moved so quickly, a lot of the documentation was out of date, or the implementations underneath didn't really live up to the promise. Do you use any kind of orchestrational services or frameworks for rapidly building out LLMs, or like agents or workloads, or what do you do?
So our team usually uses sometimes LangChain and Guardio to create very fast prototypes. But like you said, everything's catching up. So even Bedrock, we use a lot of AWS Bedrock, and now you can do a lot of these things natively in Bedrock. Now you can do a lot of workflows and model chainings and so on, which uh, they were quite, some of the first tools that came out, but now a lot of things are catching up, like you said.
Well, yeah, and it's really surprising like how robust Amazon Bedrock's coming. On the Azure side, they were leveraging OpenAI, but now they have their own generic one like Amazon Bedrock. I'm not sure why I put GGML over here. I mean, it's by the same creator, GGML and GGUF. But Llama CPP, that's something I just want to do more with because it sounds so awesome. But and it comes up a lot, but I didn't get to spend too much time there with it. Um, and Onyx is something I really wish I had time to talk about that more, because that came up a lot for compatibility for model weights. I try to remember what it does. It's a file format. It's like, is it like GGUF but a different file format? Do you remember what
I'm not sure,
Onyx is
actually.
in particular?
No, I'm not sure actually.
So this one here, um, I remember
Oh
it's a
yes,
file
I
format.
think
Yeah, sorry.
this is for interoperability, and that's the
Mm,
idea of um, kind of using the same formats or the same um, the way you encode the models and all of that in the same way, so that you can actually use the same systems across different models and across different providers and so on. Um,
mm.
I know a lot about interoperability from healthcare because everybody does what they want, and it becomes a headache, which is where the space in AI is as well, right? Every provider um, releases in whatever encoding they want and tokenizer they want, and they encode on disk the way they want, and so that makes it a bit hard to um, kind of use the similar systems across models and across. So that's great. Yeah, it's
So
definitely an interesting topic. It would make life easier for everybody if we have certain common grounds.
Hmm. I knew you knew it because as soon as I opened it up, it took you 2 seconds to know what it
Yeah.
was. App prototyping. I come from a developer background, so for me, I really enjoy AI code assistance and app prototyping. In this course, we covered Streamlight, Gradio. I think we did Fast HTML, V0, and Lovable. There's actually a few other ones that I had covered as well. And then on the other side, we have AI code assistance. So we Amazon Q Developer. I did cover that one. GitHub Copilot, Gemini Code Assist, Codium, Cursor. And these things are actually, this one has Codium and Windsurf now, which I would say I really like Windsurf. But again, things change every other day. And it's just neck and neck. These tools are changing. And so having general knowledge about the tools and not really being focused on just one thing, but conceptually understanding it is going to just make your technical path a lot easier because you're never going to be left behind. And you basically are just jumping ship constantly to new tools, but it's not that big of a deal, except when every tool costs $20. then you have to decide which one you're going to unsubscribe to. I put extra emphasis in this course on setting up the developer environment. I found that this was one of the largest challenges with working with local models, understanding how to set up Conda, installing Docker containers, pulling containers, setting up a Jupyter server, because that's a very common way. And I was actually really surprised on how many free options there are right now to learn. I think a lot of people think that, well, it is expensive to run models, but a lot of people think that it's too prohibitively expensive to learn GenAI. But I was just blown away by how many resources are right now, as every company is putting out their own Kool-Aid for you to drink, that they really want you to buy into it. And I'm sure at some point that this will change as the space matures and everybody understands stuff. But right now is like the best time to learn because there's so many free resources. It's unbelievable. But do you agree, or would you say, do you see a lot of free learning opportunities right now, or like with
I do. I
compute?
think there's a lot from all the big providers, AWS, GCP, Azure. Hugging Face has a lot of things. There's a lot from a lot of different resources, all the small startups as well. I think there's always great resources. It's a matter of time, I think, and commitment.
Well, even like in Hugging Face, they have all these projects running here, and you open it up, and they have something called like something zero. I don't know what it is, but it's like some kind of compute that is distributed that allows you to run anything. This is not exactly the one I meant to click on, but it's just very interesting that there are so many of these things running, and I'm just like, how do they have the money for all these for all this compute? But they do, and it's not showing the name of it. It's called G0 or something, or something. But yeah, it's just really interesting. One part that's a little bit hard for me to cover is GenAI security. I'm not sure if it's because things are still emergent. We do have a few friends on the security side that are going to help us out at some point to expand on this, but I imagine that this is rapidly changing to match the needs of this expanding market. Of course, learning how to work with containers, I think, is very, very valuable. There's a few different solutions, not just OpenAI, OPA, but NVIDIA has one called NVIDIA Workbench. I would just say, like, I haven't seen much tooling around containers and K8s. And when I've talked to folks in the Kubernetes or cloud native community, they're all like, I know containers really well, but I don't know anything about GenAI. And I'm like, but you know containers, right? And I think that those that know how to work with containers, that they might have an extra edge, if you will, for deploying things into production. And we definitely need people that know how to do that. Serving models, I think, is also very useful. It's unbelievable how many ways you can serve a model. Just as web servers have servers, LLMs have servers, and I also assume that general models have servers. But here's a small list of things. In fact, I covered. I don't think I covered Pico LLM, but there was a few other ones that I covered. Do you have to deal with serving models very often, or What does serving
We
models look like for you, Rola?
Yeah, so when you put a model out for usage, people have to, we call it inference or surveying. You have to put it on a machine for people to ping that machine and get their answers. And but we tend to do a lot of things native to AWS, so you can do that through SageMaker and Bedrock quite nicely. So, but yeah, if you want to put it off the out of the cloud or use your own solutions, then yes. But the main point is to actually serve the model, right? That's how you make it public and usable.
Yeah, and I think with all major providers with their specific ML platforms that they have their own inference engines or whatever you want to call
Mhm.
them. And I remember the one for SageMaker. But yeah, these ones are really interesting as well. Ray, I really stood out to me because it allows you to do things distributed. So I didn't realize that a lot of these things were that only serve on a single machine, and you have to introduce something like Ray to take VLLM and then spread it across machines, which was really interesting. There's model optimization. So I have a few here, a few things here listed. Stuff keeps shifting around here. There's another one here. I don't think I covered it, but again, merging stuff. But it was called like WebNN or something. WebNN or something. I can't remember what it was called. But it was a Microsoft project, and so that stuff's changing all the time. But one thing that I thought that might be really important is understanding the underlying hardware. I think that we really don't know what direction the Gen. Well, at least I don't know. Maybe Rola, you know, but the direction of what it looks like to build a workload, right? And what do you need to do that? Like, because I know there's different levels of models and inference, and so in my mind, I think of it as like lightweight, medium, and heavy duty inference and training. And so when I say that, I mean like if I have a computer, like a modern computer, and it can run let's say a 7 billion parameter model, uh, that's like a light that could be a light workload, something that is feasible that I could run, or something that could end up on my phone one day. And so I think, okay, what does that do for the end business or customer if now they can run this size of model locally, right? Like and you have this one capital cost of like $1,000 or $2,000 machine, and now you can build a workload that's scoped only for your office. And is that a benefit to anybody? And so because the stuff is becoming more and more possible to run on on our devices and stuff like that, I keep thinking, well, we need to know a little bit more about this, right? Um, but I don't know if you have any thoughts about the hardware side of it, or
I mean, the hardware side is interesting because these models are so large that they push the limits of what we know about hardware, right? So we're going to talk a little bit about model sizes and what that means for running them, and so understanding how these models have pushed our need for custom made chips and things like that is fairly interesting. And like you said, having edge compatible or edge optimized models can change applications and our world as we know it. And I think we saw a lot of different phones this year with their main catch being that AI now runs on your phone, right? So edge Gen AI on edge is predicted to be a very, very lucrative and big trend.
well, it'll be very interesting to see what happens. And just the other thing is just understanding how much resources these things take, because when you see or you can kind of think about how much it takes, and then you might ask like, how is this sustainable? And what's going to happen to some of these services that are out there, and how are they going to make a profit? And if I do invest my time and effort, should I go with this, or should I go with something that is more feasible that I can run at this size? And so it's really hard to say. I was talking to one of my friends, and I'm sure they're going to be really interested in the boot camp because they're really excited for the boot camp, and specifically the hardware side. And they wanted to go and spend a bunch of money because they wanted to build a home lab because they don't want to get the rug pulled on them, so to speak. That the price is going to go really high, and now they have this service that becomes like essential for their dailies, and so they're trying to invest in that. And so I thought that was an important inclusion of it. Whether I did a good job on that is up to the folks that are watching, but hopefully it is good. Then we're getting into more advanced territory, and basically everything below this line. I mean, Onyx probably is below this line too, but Everything below this line is more, I would describe as advanced techniques. Though to be fair, if you're going to be deploying models, you're probably going to want to have evaluations and guardrails and things like that. But I don't know. I think all this stuff is, and maybe this is the stuff that I didn't get to cover much in detail. This is probably where I've done the poorest job in this course. But maybe that should be its own course, because all these things are very involved. At least I think they are. Um, but do you think that folks that are becoming AI engineers, or maybe not AI engineers, but they're picking up these generative AI skills for their companies, do they need to learn super fine tuning, like know how to do it, or just like actually be able to do it, or just know of it?
I think knowing of it is always a good thing. I think it depends on the field you're in. If you are in a general field, then these models are advancing fast enough that you might not have to do it on your own. But if you're in a niche field where the model needs to be fine tuned on your specific field of data, then probably you need to know. But if you're in a general company, general use case scenario, just knowing exists is probably enough at this point.
I think the only thing that might be missing from this is all the general data skills that you need, and uh, I guess I just, maybe it needs its own data primer. I think I might have put some data in the course. I think I had some data content there, but I don't have any data specific videos saying like this is how you prepare data for ML models or LLM models. How important is data to your models? Does it matter, the data that you put in your models?
You're asking me how important data is for ML models? Is that
No,
your
I don't know. Is
question?
it? Is it like? Well, I'm just saying. Like, well, I'm just saying. Like, imagine you wanted, you have something. You're like, oh, I want to train a model, and I wanted to do something. Is 20 lines good enough? Like, how much time do you need to spend on data comparative to actually engineering LLM solutions?
So I think let's start with regular ML before LLM. Data is the bread and butter of machine learning, right? If the model learns from data, and then and so the data has to be there. It has to be of good enough quality, and it has to be pretty consistent, and so that the model learns from it. Now, in terms of LLM specifically, it's less of an issue on you. It's not it is an issue for the model, of course, because it's still learning. It's less of an issue on you because the model provider of that foundational model has done all the work. And unless you need to fine tune it or change anything about it or make it more, uh, for your field, you don't need to worry about it, right? Because fine tuning LLMs is more a privilege than um, not everybody can do it. How much data are these things trained on? Well, in the words of Jan LeCun, who is one of the pioneers of deep learning and machine learning, um, it takes 20,000 years for me and you to read. That's how much data these things get to see before they become useful. So, can you and I sit down and curate a data set tomorrow? Maybe if we commit a few months to it, but it's not for the faint of heart.
I kind of wonder, like with data sets that large, how do they know what's good and bad data when they have to consume that much data? Or I guess it just kind of evens out, eh?
No, well, that's the thing is we're seeing all sorts of things, and we see biases. A lot of the data is also scraped off the internet, right? There's biases in them. We're seeing these models being biased. They are perpetuating social bias because these data sets are not necessarily cleaned. It's also really important to know what data sets the models have been trained on. I think I was looking at some of the Google models. I can't remember which one, but it's something to the tune of 40% of the data is from social media, right? Like that's
Oh
a scary thing.
no, that's
Uh,
not good.
that's not good, right?
That's
There's
not good at
nobody
all.
who curates social media data. There's biases in social media data. There's no accuracy. So what data, and that's the importance part, for example, between open source versus open weight models, is that there's more transparency over the data that the model has seen. And so if you have a chance to look at what percentage of uh, social media data, what percentage of literature, what percentage of science, and like whatever the breakdown of the data content that the model has seen will give you a better understanding of that what that model looks like, right?
Uh,
It's like looking at somebody and saying, did this person go to college or they spend 10 years on social media? That could be a model, right? Depending on what sources it saw.
Yeah. I just think of the movie, and for those that have not seen it, you might want to see it. There's a movie called Idiocracy, where it's oh, Rola, do you know the movie?
My husband likes that movie.
There's a really good line in there. I always forget it. Bravo or Bralo. It's the quench you. Anyway, it's the product that's in the movie, but yeah, it's a bit scary to think like that they're scraping social media data. But even again, yeah, I think there's a lot of data, and it's interesting to me. But anyway, I just wanted to show people the roadmap to give an idea of the scope of it. Hopefully, that gives people an idea of the boundaries or scope of generative AI. This stuff can be a lot more complicated, so I did my best to simplify it and break it down. But in reality, if this was graphed properly, things would be all interconnected all over the place. And I made it look like a journey through one step, whereas it's really all over the place. Or if anyone's ever played the video game Path to Exile, which has like a skill tree, there's the Path to Exile skill tree. I feel like it would look more like something like that if I click into here and it's just all over the place. That's kind of what GenAI. Yeah, here it is. You go here and it goes everywhere, right? And so I feel that if we did it like that, it would look like that, and people would be like, "I'm done." But I think that this is a fair compromise here. Thank you, Rola, for helping us here in the roadmap. For folks that are watching, Rola is going to show up in a few other videos here, and yeah, that's about it. Ciao, ciao.
Yeah.